All right, we'll go ahead and get started. Hi, everybody. I'm Jordan Edwards.
I'm Chris.
And today we're going to be talking to you about how to manage your end-to-end machine learning lifecycle with MLOps. So we've got 3 topics to go over today. What is the end-to-end machine learning lifecycle? How does one take a machine learning workflow and actually bring it to production? And then how do best practices around MLOps help to accelerate your agility with getting things to production? So first off, who are your speakers? So Jordan and Chris. We both work on the Azure machine learning team on MLOps. And today, for the purposes of the demo we're going to be masquerading as an ML engineer and a data scientist. So I'm going to start by walking through sort of at a high level, what does the machine learning lifecycle look like? So you've got these sort of 5 steps. You have going and developing and training a model to solve a business problem, taking that model and packaging it so that you can use it somewhere else, validating the behavior of your model. So does your model, does it work or does it crash when requests come into it? Is it returning accurate predictions? And is your model sufficiently explainable? So does the type of algorithm that you're using meet the regulatory standards of the industry that you're working in? And then you deploy the model, whether it's as an API, embedded into an application, or running as part of your data pipeline. And then when the model is deployed, you monitor it, monitor its behavior, monitor whether customers are getting value from the model as it's running, and use that data coming back in as a signal for when you should replace or deprecate a model because it's stale. So this looks simple, but it's really hard to do right. It's significantly more complicated than doing normal DevOps, and we'll get into why. So first, I'm going to start by walking through a real-world example of doing MLOps. So we've been collaborating with the Microsoft Teams data scientists to work on a scenario around video call quality prediction. So the goal is to pull in a whole bunch of call data and video data, analyze it, generate a model, tune some hyperparameters around the model, and find the best one to register and deploy. So we're going to start by talking about the jobs to be done, the job of the data scientist and what they actually do. So data scientists are not software engineers. They're typically scientists. So a lot of them have advanced degrees, things like PhDs, and they're unfamiliar with best practices around software development. So we oftentimes call them like software engineers from the 90s. Where this typically starts from almost any data scientist we're talking to is like, oh, I got this. So the team we were working with was actually tracking all of their work in OneNote. So they'd have their Jupyter notebook, have their Python code open, they'd run stuff, they'd copy paste all the logs and metrics and just keep track of them in a OneNote, and just like, oh, I know where everything is, so it's totally fine. But this doesn't really scale beyond an army of one of data scientists. Nobody else knows what you're doing. You can't collaborate. It's tricky. So the first step in the journey for the data scientist to get things MLOpsified, if you will, is to actually turn their training process into a pipeline. So instead of a bunch of random scripts and files that they're copying around, they express, OK, this is what I'm doing for data preparation. This is my feature extraction. This is my algorithm selection, my parameter tuning, and then finally, I've arrived at a good model. So the goal of building this pipeline is now I can, things are more config-driven or declarative. I can swap things out as I'm running and iterating on my work. So now you've got consistency. It's easier to evaluate. As you train a new model, you're looking at specific metrics to know which one's better, and it's configurable. But still, it's all running on the local machine. I'm still tracking all my stuff, OneNote or a Word doc sitting on there, or even Notepad we've seen. So next step is to track your work. So we want to make it as simple as possible to let data scientists continue working the way they do, but track their work in a central place. So from the Azure platform side, and if you look at most machine learning platforms, what they'll allow you to do is have some sort of logging mechanism that will pump all those logs and metrics to a central repository and a centralized run tracking service. Now, if you have multiple data scientists that are collaborating on a problem, they can use the same code, try different methodologies, and compare the metrics across different runs. So now you have a team of more than one, improved collaboration, and ideally you move towards increased velocity at knowing when your experiment is good enough. So now I've got a pipeline, and I'm tracking what I'm doing, but the next step is, okay, now this pipeline needs to be reproducible. So I might have this pipeline referencing local data or like a SQL query that I have access to. But for others to be able to work on this and to be able to automate this in a CI/CD pipeline, you need to make your ML pipeline reproducible. And that means strongly typed and expressed code, configuration, and data flowing through the system. So if I'm training things using Python, I want to track all the Python packages, the Conda packages. If I'm using Docker, I want to know exactly which Docker image that I'm using in the end-to-end flow. And then finally, now I've got this reproducible pipeline. Now I can actually take my training process, scale it up, try different techniques, apply that pipeline to different data sets in the system. And now I've got this really cool thing that I can just bring some data in, and it will find the best model for me. So what that looks like in practice is you've got your training data, validation data, test data, different algorithms, different models. Pick the best one, evaluate it, and then cool, data scientist job is done, right? But there's more jobs and tools involved in production ML than data scientists. So data scientists use machine learning tools, stuff they pull off of GitHub, different machine learning frameworks, different types of compute. But you also need to have somebody who's going to take the work the data scientist is doing and bring it to production. So we call that the role of the ML engineer. It's kind of like software engineer is to computer scientist, the same analogy there. So you've got your ML engineer. They're typically using tools like Azure DevOps. They're the ones dealing with the Kubernetes clusters, dealing with deployment to the edge, integrating with their existing monitoring pipelines. And then finally, you've got your data engineers who are using ETL tools. They're mucking with the data lake, getting the data into a useful form for you. And there's, of course, many more roles besides that. You've got your IT ops who's going and setting up your infrastructure. You've got your data analysts. You have your business owners, and many, many more. So there's not just like, oh, data scientist is the only person required to do production ML. It's a lot of people working together. And beyond that, there's rarely one pipeline to manage it. So you've typically got at least three. Your data engineers working in their data pipelines, getting data into a nice curated catalog. Your data scientists who are working on fleshing out their ML pipeline that you saw earlier that does your featureization, model selection, hyperparameter tuning, registration at the end. And then your ML engineer who's responsible for operationalizing the work. Now that's sort of at least three different pipelines that you're going to be dealing with when doing production ML. And that same example we showed from Microsoft Teams when you include the three different personas looks way more complicated, right? So you've got three different personas, three different pipelines, all sorts of different tools, and beyond that, all sorts of different activities that they're going to be doing. So activities for data engineering, data cleansing, curation, making sure that you have fresh, high-quality data available so you can actually do reliable training on top of it. So how does Azure help to bring ML to production? So we look at it in terms of not just like, oh, Azure ML will do everything you need for production ML. It's more of how do you bring together people, the different roles, provide a well-established process and recommendations, reference architectures, and then a platform to help automate and accelerate getting your models out and getting business value out of your models and not having them just sitting on everybody's laptops and they can't go to prod. So we talked a lot about the different people that are involved, but then there's also what is the recommended process and platform when you bring these personas together. And so you've got your data engineers working on a data factory, data scientists tracking their work, and when they're done, submitting their code for review. When the code is reviewed and signed off on, you go and submit the, I have my official training pipeline now, which you feed your real production data into. Those models go into a central versioned registry, and then those models can be used to integrate with a tool like Azure DevOps to help you with actually doing your model packaging, validation, and deployment. And then, of course, on the end, when your models are running, you want to collect information on how they're behaving. that flows into Azure Monitor. Your data scientists can use that data, feed it back in, so data scientists can go and improve on their models over time. Now, we're going to shift over to a demo of end-to-end MLOps on Azure. And with that, I'm going to kick it over to Chris to show the experience of a data scientist doing MLOps.
So again, I'll be assuming the role of a data scientist. We can start by going to the Azure ML workspace portal, which is at ml.azure.com. When you get here, you'll find the home page. We'll go ahead and we'll jump into a data set. So Azure Machine Learning lets you help track and version your data sets. We'll go ahead and look at this tabular data set about employee attrition. It's pretty simple. You can generate a data profile off of this data set so that you can see the columns and see some sample data. From here, we can go ahead and go into the Azure Machine Learning Designer, where we can build a pipeline for this data set. So I already have a pipeline set up here when it loads. It's not too complex. Go ahead, it pulls in a data set, does some splitting, summarization, and then it trains a model off of this. And as a final step, and when running it, it will go ahead and register the model in Azure Machine Learning in that model registry. So it takes a little while to run, so I'm going to skip that. But we'll go ahead and go over to the models UI. You can manually register a model from something that you output. So I've already got one present locally, so we'll go ahead and make an attrition model in here. And this model was trained with scikit-learn, and because of that, as long as we supply the name of the framework and the version that we use to train it, we can actually deploy this model without having to write any code around it. So we'll go ahead and register that here.
So how does that work exactly?
So basically, we spent a long time building some good frameworks around some of our more popular machine learning frameworks. And so we're able to infer the inputs to the model and the outputs from them. So all you need to do is supply a well-known model framework, and we get to generate a scoring file under the hood for you.
So does that mean you have like pre-built environments the model can run in?
Yes.
Or, okay.
Yeah. So without going through this no-code deploy scenario, there are a couple things that you need to express, such as a conda environment that you're going to be running in, a scoring file that handles taking in your REST data and converting it to a form that the model knows, and then handling the output from that model back into a usable, typically JSON serializable format.
Got it. So it's supposed to make it easier to transition from model training to model serving. Okay, cool.
So you can see here that we can actually just give it a name. And since it supports no-code deploy, we can literally just hit deploy, and that's it. And it'll go and deploy out to container instances, and then you've got a testable endpoint that you can hit.
Nice.
Okay, and so now that the model's been registered and I've got a test endpoint deployed, I'll hand it back over to you.
Cool, thanks. So if we flip back to, So Chris just showed off a couple of different things. One of them was our new capabilities around improved data set management. So we've always had the ability to track and version snapshots of your code as you're running and integration with Git repositories. But now we've got data set management for tabular data as well as file data. And it's easy to import and export this data across language boundaries. So that attrition data set that Chris was showing off was actually in a SQL database. But to access it, all he has to do is use the datasets SDK, and it gets pulled into a pandas data frame for him to go and train off of. So the same applies if you're working in R. If you want to just mount the files locally, it's all about streamlining. I can do things on my local laptop. I can run things in cloud compute, and it just takes that data and transitions it around.
One more thing that I forgot to mention is we do love flexibility. So even though everything that I'm doing today is being shown in this visual designer, everything that you see there can be accessed through our CLI. Most of it can be done through declarative YAMLs, and we can also do it directly through our Python SDK.
Right. So we've got data versioning, easier data access, data profiling, and some more cool stuff around data that we'll show off in a second. Also, the training pipeline he was showing off. So we now support expressing those training pipelines as declarative YAML as well. So previously, a data scientist would go and author this big pipeline in Python. It's hard to understand. It's hard to diff what's changing. but now you can import and export your ML pipelines into a declarative YAML format. We found this resonates a lot with customers who want things to, again, be more declarative, more config-driven, and less of all this scary Python code in a notebook that I have to try to figure out how it works. And then finally, the other thing Chris showed off was improved model packaging and deployment. So we capture the framework, the version, the resource requirements, and this is supported for all scikit-learn, TensorFlow models in save model format, and all Onyx models. Not only do we do a no-code deployment, we also drop the model into an optimized serving image for you. So instead of doing like a normal Flask application for TensorFlow, we actually use TensorFlow serving, and for Onyx, we use Onyx runtime server. Beyond that, we now, instead of taking the model and copying it into a container image, we actually mount the model onto the container. So we've shaved deployment time for the models down from 5 minutes to around like 20 seconds. So it's significantly faster now to do a deployment of the model, makes it easier to do, A/B testing and things like that because you're not waiting as long to get feedback.
Yeah. In addition, if you use the curated environments, there's no image build step. So the whole flow used to be roughly 15, 20 minutes because you have to build an entire Docker image and then deploy that out. But now you get the benefit of using the same shared Docker image under the hood. So there's no image build. And so going from model registration to having a testable endpoint can be as low as 20 seconds.
That's pretty good. Yeah. Cool. So Chris showed off the data science flow. He created a training pipeline, published it. Awesome. Got to a model. But then, what happens next? The whole clicking to deploy from the UI is not really something that anybody would do in a production context. So I'm going to walk you through what the ML engineer would do on top of this. Cool. So I'm here in the same shared workspace that Chris was in. I've got all these models that are flowing into the system. I can see which experiment that they came from. So what I'm going to do, though, is take that model he registered and set up a release pipeline around it. So I just go over here into Azure DevOps. You see I've got a bunch of model releases going already. But first thing I need to do would be to connect my machine learning workspace to my DevOps project. And so all I have to do for that is go to Service Connections, create a new one. We do everything using Azure Resource Managers here. Right, so I can go and say, I want to connect to my Ignite workspace. You can define and scope down. I want to just use this one. I have a lot of Azure subscriptions. Just go and select that. We have a lot of workspaces in the subscription. And then scope it down to there. Right, so I've got this Ignite one. I go and set it up. I've already pre-wired it. Now, to actually go and set up a release using the service connection, all I have to do is, here's Chris's new model. I can add a new artifact type. You all familiar with Azure DevOps vaguely, assuming? Yes? OK, cool. So now, beyond just doing build, code, and package releases, I can also integrate with the model registry. All I have to do is pick the endpoint that I want to go from. And then I can see sort of all the models that are registered in the workspace, right? And so there's the attrition Python one. I added it earlier, so it's saying, hey, there's a dupe. Don't do that. And then once that's done, all I have to do is I can go into my task. We have a built-in task for deploying the model. You just say, here's the workspace, the model artifact I want to deploy, and go and wire it up that way. You can do things with no-code deployment or provide your own custom configuration. Totally up to you. And then on the, when it comes to going from dev test to prod, you can set up gates around who has to go and sign off on things, how long they have to be able to sign off. And then there's flexible gates. So in this case, I've got a query running, which will hit and say, are there any blocking bugs for my MLOps release? You can go and have your data scientist check and see, are things working as expected or not? And then you can set thresholds and boundaries on there. So this is sort of our happy path story for how do you do a controlled rollout and release of an ML model to customers. Instead of just saying, like, it's cool that Chris can do a one-click deploy to a container instance to test the model, but for a real deployment, you're going to want to go to Kubernetes and go through a real controlled process flow. Now, and here's an example of one that actually was deployed that way, and I can see here's conditions to sign off on it. Now, beyond that, I can also go in here to my workspace, So we've just added integration with Azure Event Grid as well. So I can go into my workspace, go over to events. You can see I've created a couple already. But I can actually just create a logic app around events in my workspace now. So there's different event types that I can subscribe to in the workspace. So the 4 we've added support for thus far are there's a model registration, a model deployment, a drift detection, or an experiment's completed. And again, this is pretty flexible in terms of what you can do with it. You can just hit a webhook if you want, or there's a bunch of built-in activities. So in this case, I can just say, I want to do something when a model is deployed. And there's a bunch of built-in connectors as well. Right, so I can, let's go here. Whenever a model's deployed, I can just go and say, hey, I want to send an email. At Microsoft, right? Great. And then I have actual dynamic content as well that I can just inject into the email. And so then you can stitch things together to send emails, but you can also, again, integrate with something like DevOps. And so there's all this different, we have built-in support for creating a release, but you can also say, I want to create a work item, or kick off an existing release, or queue a build, or send a request to an endpoint. Like, it's pretty flexible in terms of what you can actually go and do there. And so as an ML engineer, my job is to make sure that all the work Chris is doing is operationalized. And so he's given me that model with a link back to the run, with a link back to the data set. I can analyze it, trust that it's behaving as I would expect, and then end up with saying, OK, this model is actually deployed and trusted. And all that telemetry is now flowing to Azure Monitor, too. So let's flip back here. Yeah. Cool. So I was just showing off a couple of things there. There's integration with Azure DevOps to automate training and deployment into your existing release management process flows. And then we've got integration with Event Grid. And one example there, I think I showed off this one, but send emails or hit a webhook when an experiment's done so that I'm aware there's a new model, or I need to go look at the results of this experiment. And then you can also do some more stuff on the data engineering and data quality side. And with that, I'm going to kick things back over to Chris, who's also acting as our team's data engineer.
So I've been a little lazy lately in my job as a data engineer. And after a few weeks, I decided to go and check our dataset monitors to see how our dataset has been, or our model's been performing against the training dataset. So this is our data drift dashboard. As we can see here, I had a threshold set so that if the data is appearing more than about 60% different from the data that we were training on, we emit a data drift event. Now,
what does different mean in this context?
So data drift is detected using some covariant analysis to measure against the features that you were using in training versus what the model is seeing at inferencing time.
Got it. So it's training data versus scoring data?
Yes.
OK.
Yeah. So as we can see here, the data is looking pretty different, which means I probably messed something up when I was training. So we can go ahead and go over to Data Factory, where we have some built-in tasks to go ahead and execute retraining on a new set of data. So I've got a pipeline already set up here that will do some data prep from ADLS, and it can directly kick off an ML pipeline run. But I don't really want this to happen again. So let's go back to those logic apps and set up a listener on the fourth type of event, which you didn't mention earlier, which is dataset drift.
I was saving it for you.
Yes.
Yeah.
Yeah. So we have a culture of making sure that if you mess something up, just don't do it again. So now that this data set has been drifting very far from training, we're going to set up a logic app so that we can go ahead and automatically kick off this retraining process if we detect drift. So we can set up a logic app that listens for this data set drift detected event, and it goes ahead and kicks off this Data Factory pipeline run, which is going to retrain the model and kick off this whole flow again.
Cool. So once this is set up, when I notice the data on the scoring side is way different from how I trained it, it'll say, hey, here's some fresh data. I want to actually go and retrain.
Yes.
Oh, that's pretty cool. Thanks. Cool. So back to the normal presentation. So what Chris just showed off was a data set monitor that we'd set up. Previously in Azure ML, we had drift based on models. However, now drift is done arbitrarily based on we can compare any two data sets and see how they're changing over time. It may be two sets of training data. Doesn't need to be data coming from a deployed model. And so you can set those monitors up, get nice dashboarding experiences around it, integrates with, just send an email, or you can wire it in with Event Grid and do all sorts of flexible stuff on top of it. And then, as Chris mentioned there, you can trigger Data Factory, and now we have built-in support from Azure Data Factory as well to call into Azure Machine Learning. So you can wire in automated retraining. You can also wire in batch inference from Azure ML as part of your end-to-end pipeline. And so the net goal here is to help with lighting up what we call an enterprise-ready MLOps process, where you've got data engineers in Data Factory, data scientists working in Azure Machine Learning, and your ML engineers working in DevOps. So I know this process is super complicated, so I'm going to spend some time to recap. So just talked about a lot of new stuff in the product. There's improved data management, support for doing declarative ML pipelines, integration with Azure Event Grid, no-code model deployment for scikit-learn, TensorFlow, and PyTorch models. Onyx models. Tighter knit integration with Azure DevOps, dataset drift analysis, and integration with Azure Data Factory. So again, what is this whole MLOps thing all about? It's how to bring ML to production. So people, process, and platform to automate ML-infused software delivery and provide continuous value to our users. And so on the people front, there's, again, different personas with different priorities. You have data engineers who are focused on, I want to make sure I have clean data available for everybody else to consume. You have data scientists who want all the data in high quality, featureized for them right away. You've got your ML engineer who's focused on putting the ML into production, whether it's deploying the model or taking the training pipeline that Chris built on some public data and applying it to my encrypted production data, and then the ones consumed with the performance and operational metrics of how long are the training pipelines taking to run? Is there resource contention happening? How long are data scientists waiting for their jobs to complete? Same thing that your DevOps folks are doing for traditional software engineers, but your ML engineers are focused on doing this for your data scientists and making them more effective. And then, of course, you have IT in the middle focused on maintaining all of that infrastructure, governance, and concerned about speed versus safety to make sure things aren't getting too far ahead of where they should be. And then the process and the platform together is you have your data pipelines, your ML pipelines, approval flows happening. So one of the things we didn't show off here, but when Chris was pushing or creating his ML pipeline, he would first take it and submit a code review on it so that somebody else had looked at it prior to doing the deployment. Integrates with the model registry, integrate with a managed release pipeline in DevOps. And so that's, again, how the whole process flow we would expect to go. And so in summary, there's the 3 Ps. So on the people side, machine learning success is going to require cultural change. When we go and talk to a lot of customers, their data and AppDev and data science teams are often split and not communicating well with one another. And so our goal is to help educate them in how to set up their organizations to be successful in doing production ML. The different personas have different needs and require different tools. On the process side, there's the requirements to have policies and governance in place on who can do what. So another thing we didn't show off explicitly, but Chris has permissions to deploy a model to dev test, but he doesn't have access to do a production model deployment. So how do you separate the right roles and responsibilities? And the final thing is on the platform side, how do you guarantee that the platform allows you to do reproducible ML? And we manage that with code, data, environment management in the system, the model registry with that clear lineage back to where everything came from. And the goal is to let you scale up, scale out, collaborate, and share. And then finally, I hope you all enjoyed this session. We have a bunch more sessions coming up on Azure ML later today. Particularly if you're the ones managing MLOps for your enterprise, I'd recommend the enterprise readiness solution later today. That's going to go through how to use VNets, how to secure your workspaces, and how to define custom roles to separate things in there. Also, there's a theater session later today on how to do data versioning and data set management. Otherwise, feel free to learn more, dig in, and let us know if you have any feedback. Thank you. And we can take questions.
Yeah, we got some time for questions if anybody.
Yeah.
So currently trying to do like a pipeline for model, and I'm struggling with all the various Python scripts are used basically.
Yeah.
Steps. And what I want to do is basically in each of those pipelines refer to those scripts as like a template, like pipeline template, like a remote for like a remote pipeline.
Sure.
And I can't do that because they're in Python. So what I'm doing instead was just injecting them directly to the pipelines of each as an inline script, but it's really ugly. Is there a better way to do that?
Yeah, so if you use a machine learning pipeline, so his question was, hey, I have a whole bunch of Python scripts I want to stitch together. How do I easily do that without doing code injection? And the answer is if you actually set up an ML pipeline, you can configure Python script steps with data dependencies and publish those and make that be your sort of reusable thing you can invoke from your build.
Artifacts.
Yeah, exactly. Yeah, that is artifacts managed in the system, and that they'll all get snapshotted together when you publish the pipeline. Yeah. We have some examples in our Git repository as well, which would be helpful to look at.
Do we put a link up to that?
The documentation link should have a link to the notebooks, so you can go and look there. But yeah, thanks. Any other questions? Yeah.
You talked a lot about the roles, right?
Yeah.
Data scientist and ML engineer.
Yep.
In your experience, what's the ratio between the roles? Like, how many are there of each layer? I know it's an impossible question to answer in general, but in your experience.
Yeah. So typically there tend to be. It depends on the organization. In some orgs, they have a lot data engineers who are starting to dip their toes into doing data science. In some, you have a small team of data scientists and a larger team of ML engineers building on top of their work. It just depends on the domain industry. Yeah, there's no real answer there. However, the one thing we found is a lot of organizations are trying to hire ML engineers right now because they'll have data scientists and data engineers, but they're not really able to get the ML running in production. Yeah. Yeah.
So what is the ML engineer's responsibility for scaling these models and also like controlling the cost, like cost optimization?
Right. So we mentioned briefly the integration with Azure Monitor, but in terms of the costs, so we let you track and monitor how long your experiments are taking to run, when your models are deployed, how long they're taking to make predictions, and then for the compute that's going under those, how much that compute's actually costing you. So the net goal is I can say, hey, I have this model linked to this experiment. It cost me this much. Is anybody actually using the model? Is it worth continued investment? Like, do I want to turn the retraining pipeline on for a model or even automate training around a model that's not getting a whole lot of traffic inside of the system? And so we try to pump as much information as possible into Azure Monitor and let you make insights and decisions based on top of that.
On top of that,
Scalability, like, how does it scale? Like, how is it scaling?
so on top of that, from a COGS perspective, we also have the ability to do model profiling. So prior to deployment, you can profile a model to figure out the CPU and memory consumption, and we can spit back a recommendation for you for that model. And then once out in deployment, as long as it's deployed out to AKS, you do have the ability to configure an autoscaler for a minimum number and a maximum number of replicas. It'll scale up and down based on a utilization percentage of the number of backends that are available.
And then, on the training side, the compute nodes, you can set quotas on how many cores you're allowed to spin up total, how many GPUs your data scientists are allowed to use, and those will auto-scale up and down as you're running.
So for the profiling, like,
Yeah.
you guys like doing like kind of load testing or stress testing to make sure?
So that's what the profiling actually does. He works on it, so
Yeah. So the profiling basically does a straight stress test to see what the capacity of your model is. So we spit back things like the QPS that it can perform at, the latency per request, and some percentiles as well, in addition to the actual CPU and memory consumption.
Other questions? Yeah. Yeah.
You have like a REST endpoint available where like the model is hosted and the next time you do like a model.predict?
Correct. Yeah. So the thing that Chris didn't show at the end of his deployment, can we just flip back to? Yeah. So when you deploy the model as an API, yeah, flip to mine. So the model API here, right? So I can go into a model, and then we have. Give it a second to load. So we have a REST endpoint that you can call into to get predictions from the model. You can also call in from the Python SDK. And then we will give you a Swagger as well and let you auto-generate a client to consume the model from different languages. Yeah?
So in your demo, when you were registering a model, you essentially did it manually. Is there a way to automatically register a model that could, well, evaluates better, for example, a
Yeah.
specific metric? And also, when you upload it manually, there is no way to trace back to which
Correct.
data was used?
Yeah. So that's the issue with the manual. If you're using an ML pipeline, you can add a register model step at the end that will do the full lineage between the run that it came from and the data sets that are linked to it. And so those ML pipelines can be automatically triggered based on the event grid triggers that we were talking about before.
So I have a pipeline example I can show you. 1 second. So if we actually look here, add a pipeline endpoint. So you can wire up a training pipeline that will do exactly what you're talking about, where it will basically do train, evaluate, and then register at the end. And then in this evaluation step, the code that's actually running behind it, let me go into one of these runs. So if I look at the snapshot of the code, so again, we keep tracks of all the code and data that you're doing when you run the training pipeline, right? If I look at the snapshot of the code, then here's the evaluate step that I'm running. And then what I'm actually doing here is I'm trying to. It doesn't want to. There we go. Yeah. So on the evaluate side, it'll go and find my model currently running in production. In this case, it's just grabbing the mean squared error from it. It'll look at the new model that I've trained and see if the metric is better. And it'll use that as a pass-fail signal for whether it wants to register a new model. And so you can just stitch all these things together. And again, you can do that in the visual designer, or you can just do it in a Python, whether it's in a notebook or in Python scripts, or in declarative YAML. Yeah, cool. Other questions? Yeah.
So you talked a lot about Python and the pandas data frames. What about support for Spark and larger models? Because I know Spark integrates from Databricks into
right.
So do these pipelines work?
So yeah, you can pull the same data set into a Spark data frame. The pipelines can all run against different types of Spark compute. And you can also register PySpark models in the system the same way. So it's nope, we don't care at all where the model was trained. You can do what Chris was talking about, where you go and upload a file, or the nice thing about doing it from an experiment, if you are doing it from there, is we have this nice little audit trail where you can see where the model came from. I trained a lot of models earlier. Yeah, so if I click on this model, I actually have a pointer back to the exact run that it came from and the code behind that run. So the rec is, if you're doing production ML, ideally you have a pointer to the code and data you used to train it in the first place. And so that link works both ways, right? So I can see here's the registered model, things like that. Yeah. Other questions? Yeah.
Does that work also with legacy R script libraries that are certified? We don't want to change the library?
You can bring R models into the system as well. Yeah. You don't have to train them with us. But if you did use RStudio with integration with our logging, then you would have that lineage. But there's no requirement that you train an R model with us. You can just use us for model registration and deployment. We do support R, and we have RStudio built into the product too. Yeah. Any other questions? Looks like no. OK, great. Read the docs. Let us know any feedback you have. Thanks so much.
Yep. Thank you guys again.